Hi viewers, today I am going to explain how to calculate SPI and SPEI. But before we get to the calculation, the very first step is to download your data. For this tutorial, we will use NEX GDDP CMIP6. That dataset is comprised of global downscaled climate scenarios derived from the GCM. This is the link that you copy it and paste it. I will also provide you in the description. Just click on S3. You can also read this PDF. Okay, and we are working on NEX GDDP CMIP6, and I am working on Pakistan, so I am selecting my GFDLESM4. We are working on historical data. Just click on it. Yeah, today I will cover TASMIN. It's minimum temperature. We will download V20.NC. It has been updated 3 months ago. I already prepared the script for you, and the best part is that this method is fully reproducible, easy to follow, and works for any country or region in the world. Whether you are writing a research paper, preparing a report, or just exploring climate trends, this workflow will give you publication quality graph and maps in no time. Yeah, download the shapefile. It's up to you on which websites you want to download your country shapefile. This is just for educational purposes. And just find P, because I'm working on Pakistan. Just click on shapefile and download it. Once you download the shapefile, our next step is place both netcdf file and shapefile in the same working directory for easy access. Okay, launch the R. Just go to session, and set working directory where you have download your data. I have downloaded in CMIP6. Open it and check it. Yes, I will also teach you how to download it automatically from this script. But before that, we should run the required libraries just on one click. And run it and check the NC files. I have downloaded all the data for minimum temperature from 1960 to 2014. Okay, you can replace your study area over here and then run it. And then crop, mask, and store the dataset. Just select it and run it. it will take 5 to 6 minutes. And the interesting thing is that you can monitor your crop, mask, your NC files for your region of interest. You see 1960, 1961 that has been finished and completed. So let's back to this script, how you can understand it. Just next, you don't need to change this one. Prefix, yes, this one. You change this one, task minimum, and also 1 second I can show you. For example, you are working on S3 NEX GDDP, because I am working on GFDL ESM4. I don't know about your region of interest. You should select your relevant model and put the name over here. Replace it with GFDL ESM4 with any model. For example, like this one. Just write these spells. Okay. Once you selected ESM4, then historical, other things are same, and just need to change this variable, minimum temperature. And then list all objects in that prefix. You don't need to change anything over there. Filter ending with v2.0.nc. I told you this one is updated 3 months ago. Okay, don't download this one, just download this one. That is why I am filtering v2.0.nc. And then extract air from the file name. You don't need to change anything over here. Filter for 1960 to 2040. Keep in mind that you can also change it air, because I have started with 1960 to until 2040, because data is available until 14. Drag it down and check it on number 3, and you see that historical data is available until 2040, v2.0.nc. And here you don't need to change anything. You just need to change model name here and the variable that you are looking for, maximum temperature, minimum temperature, or precipitation. And also modify the air. And just select it and run it. It will automatically download all the NC file. I can show you in CMIP6. You see that minimum temperature, model name, historical, and 1960 to 2014. I have already saved the maximum temperature file for the future use to calculate SPI and SPEI and other indexes. And today we will save for T minimum, for minimum temperature. And just wait it for cropping and masking. Yes, then I will show you how we can find the start date and end date from the NC file that we have cropped and masked with our region of interest. I'm not hiding anything from you. Yeah, it has been completed until 1990. Wait for more 2 minutes. I hope it will be finished in a 2 minutes. And one more thing, also extract shapefile and put it in CMIP6 folder. I have already put it. And let me know if you find any error. Just paste it in a comment. As soon as possible, I will respond back to you. Yeah, you monitor it. We are going to complete our crop mask with our region of interest. Yeah, we are approaching to 2014 very soon. And you can also check that these are the same file that we have downloaded in our folder. We have 55 files from 1960 to 2014 and 53 has been finished. Only 2 files has been left. Yes, everything has been finished successfully. Yes, you can find the pop-up message or rasters combined successfully. Just click on Raster and you can find all the information from there. Just copy it 1960 to over here, whatever the date you are finding, you did find, and same for end date and paste it over here. Yes, we convert our raster data into data frame. and we can also check it. It's pivot wider data from 1962 until 2014 corresponding with months 01, 02 with X and Y, it's longitude and latitude. And same like convert wider to longer, it's RDF long, and you can find it longitude, latitude, air month, minimum temperature, it is in Kelvin. I have extracted year, month with month's name and so on. Just save it, this file for T minimum. After completing 3 videos with maximum temperature, minimum temperature and precipitation, I will show you how we can calculate SPI and SPEI and other climate indexes from these 3 variables. Previously I have saved, I can show you, I have saved, where is my data? This one. I already have saved T maximum temperature, and now we have saved T minimum temperature. Hopefully you will also be able to save these 2 files successfully. Okay, calculate months and convert Kelvin to degree centigrades, and color palettes, intervals, breaks. You can also adjust color according to your likes for this one, this one, this one. And just make a map. You don't need to change anything. You can also display the map over here. It will not take time. For the line plot, one second, yes, you can find historical map for 12 months from 1960 to 2014. See, mean, minimum temperature. There is no need to edit anything. Everything is perfect, legend is perfect, fonts are perfect, and title is perfect. Yeah, for line plot, just drag it until this one. You can find the line plot, everything is perfectly fine. Yeah, set the themes for all graphs and maps. Yeah, now we are able to calculate any type of index for publication purposes. Here we define a custom function to calculate sense slope, which is a robust estimator of the trend in a time series. In simple terms, this function tells us how fast a variable like temperature is increasing or decreasing per year. Just click it. And yes, we can calculate the percentiles. Yes, P10 is the 10th percentile representing cold night, and P90 is the 90th percentile representing hot night. You can also make the map. Just merge them into X and Y. Yes, for this one. Indexes, yes, with longitude, latitude, year, And what is TNX? TNX is the annual maximum of minimum temperature, and TNN is the annual minimum of minimum temperature. And TR20 is the tropical nights, and FD is the frost days count, and TN90P is the warm night percentage, and TN10P is the cold night percentage. This code calculates per cell trends in warm nights over the years, quantifies the rate of change, checks the statistical significance, and prepares visual markers. Let's just drag it. And this section creates a map showing the statistical significance of trends in TN90P, that is percentage of warm nights, using Mann-Kandal p-values. It also adds stars to indicate significance level of trends. P less than 0.01 is highly significant, and P less than 0.01 or NS. NS is not significant. This visualization I can show you. First run it, and then this one. Just click it, and you can find it over there. Yes, you can find the values for sense slope for TN90P, and also you can create map for significance plot. Just drag it and visualize it. Yes, you can find the stars. NS is the non-significant, and we have 3 stars, 2 stars, and 1 star. 3 stars mean P less than 0.001. 0.01, yes, 3 stars. And the 2 star is, where is 2 star? Yeah, this one is 2 star, P less than 0.05, and 1 star. We can also find the 1 star, where is it? Yes, this. 1 star is P less than 0.1. And we also find NS, it is non-significant. Okay. Then we calculate T90P for line plot. Just drag it and run it. Click it and run it. Yes, I can explain it for you. The plot includes points for each year, that labels for the minimum and the maximum values. And the title and subtitle showing sense slope and Mann-Kandal p-value. This plot helps us quickly see whether warm nights are increasing or decreasing over time across the entire region and how strong and significant that trend is. In the end, we need to combine the plot and save it as go to CMIP6 and find that final map and graphs and see that you don't need to edit anything from any software. Okay guys, see you in the next video for precipitation data.